We talked about the Pythagorean theorem before. We are going to re-talk about the Pythagorean theorem, but since we've been working with our radicals and simplifying our radicals, that's how we're going to leave our answers. Okay. So I'm going to cross this out. Let's just remember that when we have a right triangle, what do we call that piece that is across from the right angle? The hypotenuse. This is called a leg, and this is called a leg. Now, we've talked about the Pythagorean theorem before. Okay. Our legs we're going to label as A and B. Our hypotenuse we label as C. And then the Pythagorean theorem is this right here. A squared plus B squared equals C squared. Okay. And we've done that before. Okay. This time we're not going to give decimal answers. We're going to give answers in terms of simplified radicals. Okay, so then this is the first example I want you to write down. Which one's the hypotenuse? 14. So when we set up the Pythagorean theorem, we're going to set up x squared plus 7 squared equals 14 squared. Make sure the hypotenuse is the one that's the loner on the other side. Yeah.
Does it matter if the x squared is switched with the 7 squared?
It does not. Addition is a commutative operation, so it can be x squared plus 7 squared or 7 squared plus x squared. So 7 squared is 49 and 14 squared is 196. Okay. When we subtract 49 over, can somebody tell me what 196 minus 49 is? 137? 147. All right, so now we know that we need to square root both sides so that x is the square root of 147. But what we're going to do differently today is we're going to just simplify the radical as opposed to putting that in our calculator. So do we have a perfect square that divides into 147? It's 49. 49 times what? So since 147 is 49 times 3, then we can write our answer as 7 square root 3. Say your question again.
Will we ever learn how to use 7 squared root 3 later?
What do you mean by use it?
Like, this is the simplified version of what does this mean, basically? Will we be able to use this later to get a definite answer?
I mean, this is a definite answer. I guess I don't understand your question. So this is like the exact answer. Whereas like if we put the square root of 147 in our calculator, we'd get 12.2 blah, 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 and then we round, okay? This is the exact answer, okay? Okay, let's do another one. We'll do one where the hypotenuse is missing. That's not a great triangle. 4, 6, 8. Okay. So in this problem, x is our hypotenuse, so we're gonna write 4 squared plus 6 squared equals x squared, okay? Doesn't matter if it's 4 squared plus 6 squared versus 6 squared plus 4 squared. Addition is commutative, so we're good.
When I turned to this page, I had pencil, like red pencil marks of these exact equations. Even though we haven't broken yet.
What?
In-
Is that like, let me see.
Are you sure you're right here? I had red pencil marks even though I don't have one.
Is there any other markings, like if you turn the page to like the next one?
I mean, that's better.
Huh, that's really weird. All right. I don't know. All right, what's 4 squared plus 6 squared? 52? Okay, so we are going to square root both sides. So x is the square root of 52, but we know 52 is divisible by 4 times what? 4 times 13. So our answer is 2 square root of 13. All right. Now we have what's called a Pythagorean triple. Have we used that term in here yet?
I mean, I think we might have used it.
No, we never used it. Okay, so a Pythagorean triple are 3 numbers that satisfy the Pythagorean theorem. Okay, so like if I grab this right here, 3, 4, 5. 3, 4, 5 is a Pythagorean triple because we can take 3 squared plus 4 squared equals 5 squared, and we get a true statement.
Whoa.
So,
So what would it be like?
Yeah.
Yeah.
So 3 squared plus 4 squared equals
No,
5.
what would it be Yeah, like?
yeah.
4, 5, 6. Yeah, I want to. Like 7, 8, 9.
Well, let's talk about 3, 4, 6. Is that what you said? 3, 4, 6? 4, 5, 6. So 4 squared plus 5 squared, does that equal 6 squared? We would have 16 plus 25, does that equal 36? No. So these do not make a right triangle. Okay, because they don't satisfy the Pythagorean theorem. Now we're going to talk about here in about 5 minutes what kind of triangle this tells us it is, but we'll get there. Okay. It's not isosceles. All 3 of those are different.
Wait, but don't.
Yes, but we can, so this is a right triangle. We're going to be able to tell whether this is an acute or an obtuse triangle.
But that still makes a triangle.
I feel like obtuse,
Well, we
but
can use this as
Yes.
one.
like I feel like
Not that I can remember right now. Okay. All right, let's pick another one. Like if we look at 5, 12, 13. 5 squared plus 12 squared equals 13 squared. Hey, is 25 plus 144 equal to 169? Okay, so those are right triangles. And because they're right triangles, then their numeric sides are called Pythagorean triples. Seriously. Can we not do that, please, Sam? Yeah, don't let me. Okay. All right, so go ahead and look at the next page. Okay. So, oh, I'm sorry. The converse of the Pythagorean theorem, if a squared plus b squared is c squared, then we have a right triangle. So, like, for the rest of this page, we're just going to determine what kind of triangles we have. Okay, so let's say I give you a triangle and we're not sure if it's right or not. We don't know if this is a Pythagorean triple or not. Okay, but I want to know, is this a right triangle? 7, 8, and square root of 113 are our sides. Okay, so if we want to determine if it's a right triangle or not, then we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. Potentially. Okay, because the square root of 113 is our longest side, so that's going to be our potential hypotenuse, right?
The hypotenuse, what is the square root of 113? Square root of 113.
Could somebody answer Sam's question? Wouldn't the square root of 113 squared equal 113? Yes. And then we have 49 plus 64. What is that? 113. So yes, we have a right triangle.
Wait, so if you didn't put it in that order, would you have to just keep doing it?
So you would never not put it in this order because the longest side has to be your C. Okay.
Never assume. Never
Yeah.
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 You know what happens when you assume.
What if it's not on the scale?
All right. Now, let's go back to our 4, 5, 6 triangle that we were talking about. We decided it wasn't a right triangle, but the Pythagorean theorem can help us decide, okay, is it right? But if it's not right, is it acute or obtuse? So if a squared plus b squared is bigger than c squared, we have an acute triangle. If a squared plus b squared is smaller, so if c squared is the bigger side, then we have an obtuse triangle. Okay, so let's go back to Alexa's, was it 4, 5, 6? Okay. So we have sides 4, 5, 6. Okay, which one are we going to use for C? 6. So let's try 4 squared plus 5 squared equals 6 squared. What's 25 plus 16? I'm gonna have you try that again. 41. Okay, so who is bigger, C squared or A squared plus B squared? Okay, so since C squared is smaller, it is acute. Are you hungry? That was unfortunate timing, Nora. If it makes you feel any better, my stomach's doing the same thing. I'm starving.
It's not even that loud though.
I had breakfast, but nobody is gonna complain if you bring banana bread, okay?
It's not all the way cooked, so like,
Well, yeah.
I'm afraid I'm gonna get salmonella.
So maybe you should cook it all the way. All right, let's try this one. 10, 24, 26. Okay, what kind of triangle is this?
I also put too many chocolate chips in it.
Hey, what's C?
It's like
26.
Okay.
So 100 plus what is 20?
What is 24 squared?
576.
So 676? All right, what's 26 squared?
676.
No way.
Dude.
So it is a right triangle. Very good. So now, last example, we're gonna do a triangle that has sides of 5, 8, and which one is our C? Okay, so we have 5 squared plus 8 squared equals 10 squared. So I know 10 squared is 100. What's 25 plus 64? 89. So this time C squared is bigger. What does that mean? We have an obtuse triangle.
The numbers are also same as me.
Interesting. Okay, so for your homework,